Alright, what we're going to do today is we're going to do the Taylor series generated by f of x equals the square root of x plus 1 at a equals 0. The Taylor series is defined as a summation from 0 to infinity of f of n times a over n factorial times x minus a to the n, which is also can be defined. This is also given to you by the formula f of a plus f prime of a times x minus a plus f prime of a times x minus a squared over 2 factorial, which eventually becomes f of n times a times x minus a to the n over n factorial. In this one, we take f of x and we first find it f at 0, which gives us our first term, which is 1. And then after that, we keep finding more. These are the coefficients, so we keep finding more coefficients. I took it up to the fourth derivative. You can keep going. And so, yeah, I get 1/2, and then when I plug this in, I divide the second derivative by 2 factorial, which is negative 1/8. Take the third derivative, we divide it by 3 factorial, which is 1/16. And take the fourth derivative, and divide that by 4 factorial, which is negative 5 over 128. I then now put it into the specific formula for this specific function, which is 1 plus 1/2 x minus 1 over 8 x squared plus 1 over 16 x to the third minus 5 over 128 x to the fourth. Now, to find the general formula for the Taylor series, what we first have to do is ignore the first term for now, and then we look at the pattern of the next terms, which comes out to be 1, negative 1, 3, negative 15. And then, so to achieve that specific pattern, we have to do negative 1 to the n times 2n factorial over 2n times n factorial. Now that you've established the top, you now have to look at the bottom. The bottom can be achieved by 2 to the n plus 1. After that, we put it together. So now you have negative 1 to the n over 2n factorial over 2n times n factorial all over 2 to the n plus 1. You simplify that and you get negative 1 to the n times 2n factorial divided by 2n times 2n plus 1 times n factorial. Now, to get the complete term, you have to plug it into the Maclaurin series, which is a form of the Taylor series. That can be established by f to the n plus 1 of 0, which that equals negative 1 to the n times 2n factorial over 2n times 2n plus 1 times n factorial. And then we plug it in and we get summation from 0 to infinity of negative 1 to the n times 2n factorial times x to the n plus 1 over 2n times 2n plus 1 times n factorial times n plus 1 factorial. And now we've gotten that, we have to add back the first term that we previously ignored. So your final answer becomes 1 plus the summation from 0 to infinity of negative 1 to the n times 2n factorial times x to the n plus 1, all divided by 2 to the n times 2n plus 1 times n factorial times n plus 1 factorial. And that is how you do this Taylor series, generated by f of x equals square root of x plus 1 at a equals 0.